Hi, I'm Shiv, and today we're going to be talking about how Google Maps actually work. Okay, so let's go back a few years. Let's go back to, say, the 2000s. You want to go from point A to point B. What will you do? You'll take out your trusty old paper map, you'll plot point A, you'll plot point B, and you'll make the path between point A and point B. Yes? Now, how did Google take this process to Google Maps? So obviously there are four main components in this process. The first being your map, the second being point A, the third being point B, and the fourth being the path. Okay, so point A is the starting point. So let's take out your phone in Google Maps. The starting point is the location of your device in most cases, yes? Point B is the destination. So you enter that. So we have point A, we have point B. Now let's talk about the map. Okay, so to get the map, so Google Maps started a journey by buying this company called Where2 Technologies. Now it was a mapping-based company. Now Google needs data about the various countries in the street layout. So what it did, it contacted local and global institutions for information regarding the roads, the highways, and all of that stuff. And unfortunately, like these institutions, they do have data, but they don't have like complete data, or sometimes they don't have the data at all. So Google went for the second approach, which was satellite imaging. Yes, so it took a satellite. Suppose this is a satellite image and this is a maps image, and well, this is a satellite map image. So it can use the satellite image to generate map images. And for example, on Google Maps, you can see the outlines of buildings when you're traveling. That is also done using satellite imaging. Okay. So the next step Google took was Street View. Wait, isn't Google Street View like used for Street View? I mean, it is obviously used for that, but it is also used for verifying the information that we have from the previous sources, and reading the street road symbols and giving you more accurate, giving you a better experience while using Google Maps. The next approach it used was crowdsourcing. So what does crowdsourcing mean? Crowdsourcing means me, the user, we are volunteering, we are sourcing this information to Google. So say I'm a local businessman and I want to showcase my business in Google Maps. So I'll register with Google Business and I'll put the location of my business on the maps. Yes. Or for instance, you're traveling in a road and you see construction work. So you can report that there's construction work going on here, or there's an issue with a particular path. You can report that issue and Google will like look into it. Yeah, so that's called crowdsourcing. And the last approach it uses is, well, Google is a database company, yes. So the last means of information it uses is, well, you. So all the location data that you have while you're traveling using Google Maps, that is all analyzed, and that's also used to give a better experience while using Google Maps. Okay, so now we have the map, we have point A, we have point B, and all we need is the path between point A and point B. How that's done is it's done using algorithms. Yes, so Google mainly uses two algorithms. The first one is called A star algorithm, and the second one is called the Zig Star algorithm. So let's talk about those algorithms now. And if you want to skip the technical parts, you can click on the timestamp here and you can skip them. So yes, let's go.
Okay, so hi, and now we're gonna do the Zig Star's algorithm. Okay, so what is the Zig Star's algorithm and what are we gonna do in the Zig Star's algorithm? Don't worry, I'm gonna keep this as simple as possible. So, okay, this is a Google map, okay, and I wanna go from this is point A to point B, okay, and okay, so suppose I am taking this path, okay. Now there are multiple turns over here. So when I'm over here, I have a choice to go here. When I'm here, I have a choice to go here. When I'm here, there's a choice for here. There's a choice for here. So whenever this path is branching, okay, whenever I have a choice as in where to go, all these points are called nodes. Okay, nodes. This is a node. This is a node. This is a node. Over here, we can go like this as well. So this is a node, this is a node, this is a node. All of these points are nodes. Okay, so what Dijikra's algorithm does is it takes one of the nodes, which is the starting node in Google Maps, and it finds you the shortest distance to every other node. So if I'm doing the Dijikra's algorithm and I've chosen A as the starting node, I'll know the distance from A to say here. as well, and I'll know the shortest distance from A to here as well, and the path it's taken. Okay, so let's see how that's done. So this is a very simple instance. So these are nodes. Okay, so this is A and that is B, and in between you can just label those nodes. These are very few, but again you can just repeat this for a large number of nodes. Okay, so how does it work exactly? Let's talk about that now. So first you have to go to your starting node. So the distance to go to A is 0. Okay, now you can't directly so I'm choosing A as my starting node. So right now I'm not at A, yes, so I can't really go to C or B because there is no path, the path starts from A. So right now C and D and D and E and F are all unreachable, yes, so the distance to them is infinity. So now I'm at A and I have chosen A as my node. Okay, so let's see what we'll do here. Okay, so now I am at A, yes, and the distance from A, so till A it was 0. Now the distance from A to B is 7, distance from A to C is 12, yes. Now let's see which is the shorter distance, and obviously you can't directly go from A to D because there is no direct path which takes you from A to D, yes. So right now it's infinity for D, infinity for E, and infinity for F. Okay, so the shortest distance between 7 and 12 is 7, so we choose B as our next node, yes, we choose the shortest distance as our next node. Okay, so now we chose B as the next node, yes, so we are at B now, and we know this was 0, this was 7, and this is 12 right now, yes. Now suppose we have two paths now, B to C and we have B to D, yes. Now B to C is 2, and obviously as I told you in the beginning, our whole goal in the Zig Star algorithm is to find the shortest distance from the starting node, which is A, to each and every other node, yes. So when we're going from B to C, we will include the distance that it took us to get to B from A. So right now it's 7, yes, so 7 plus 2, that's 9, and 9 is less than 12, so C becomes 9, yes. And D, it goes from infinity to 7 plus 9, which is 16, and these remain infinity because there is no direct path to them right now. Okay, next, the shortest value amongst these is 9 because 9 is less than 16, yes. So yes, so we choose C as the next node, and the shortest distance to these is 0, 7, 9, and D was 16, yes. So from C there's only one option, you can go to E, so which is A to B, which is 7, B to C, which is 9, and C to E, which is 19, yes. So this goes from infinity to 19, and this still remains at infinity. Okay, next, the shortest value amongst these between the nodes we have not chosen yet is of D, which is 16, so we'll choose D next. So this is 0, this is 7, this is how much, 9, 19, 16, and okay, now we are at D, yes. So from D you can go to A to B, B to D, which is 19, and from D you can go to F, which is D was 16, yes, D to F is 17. So, and E, we know the value is 19 right now, so those are the final values, because E to D is 19 plus 4, which is 23, which is higher than 16. So we have our final values over here of the shortest path, which are 0, 7, 9, 19, 16, and 17. Okay. Now the proper way to represent this, I'll show you that as well. So this is A, this is B, this is C, D, E, and F. Okay, so I started A, so distance to A is 0. So yes, we have gotten to A, done. A to A, the distance is 0, I mean that's obvious, yes. So next, from A to B the distance is 7, A to C the distance is 12, this remains 0, these are still unreachable right now. The smallest value between 7 and 12 is 7, so we choose B. From B we have two options, B to D and B to C. Yes, so B to C is 7 plus 2, which is 9, and that is less than 12. So we'll replace 12 with 9. This process is called relaxation, but just to keep it simple, if you're going via another path and you get a value which is less than the value that you have right now, we'll just update the value to the lower number. Okay, yes. So we have A to A to B, and A to C. Okay. Now also from B you can also go to D as well, so which is 7 plus 9, which is 16, and these two are still infinity. So the next node we're choosing is C, which is 9. So we did 0, 7, 9, 16. C to E, we only have one option, so this is 19, and this will still remain infinity. So we have this, and the lower, so we haven't visited these two nodes right now, D and E, yes. So the lower value amongst these two is 16, so we'll choose 16. We're at node D now, and D to F is 1, so that is 16 plus 1, which is 17, and this is 19. And lastly we'll visit node E, because that the from F you can't really go anywhere, and from E you can go to F, but that distance will be 19 plus 5, which is 24, and that's greater than 17. So we have the shortest distances. So this is A to A to B, A to C, A to D, and A to E, and A to F. This was the Zig Star's algorithm, the shortest distance from one node, the starting node A in this case, to every other node. Now the Zig Star's has one drawback, and I'll show you that drawback. Suppose we are in a scenario where there are three nodes like this, and the distance from A to B is say 5, B to C is minus 15, C to A is 5, and we're going to find the shortest distance from A to C. Yes, so we go from A to B, that's 5, we go from B to C, which is minus 15, that is minus 10. Yes, so we have the shortest distance A to C, minus 10. But what if I go from C to A? So that will become minus 10 plus 5, which is minus 5. So do you see where I'm going? So every time I do one instance of A to B, B to C, and C to A, I'm doing a cycle of minus 5. So the shortest distance is minus 5 times n, where n is the number of times I'm doing this iteration. So that basically makes it minus infinity. The shortest path from A to C is minus infinity in this scenario. So this scenario is where I have a loop where the negative component, which is 15, is outweighed, like it outweighs the positive component. So 5 plus 5 is 10. 5 plus 5 is 10 minus 15. The net component is a negative value, and I can loop that value. Over there, the Zig Star has a problem. So that was the limitations of the Zig Star. Okay, so now that we're done with the Zig Stars, I'm gonna quickly go over a few things that I skipped while explaining the Zig Stars for the sake of your easier understanding. So the first technical term that we skipped is called relaxation, or relaxing the nodes. So what happens in relaxing is, so let's go a bit up. Okay, so suppose over here, okay, the value of node C right now is 12. Okay, so A to C, the value was 12, and we went to B node, and the value of going from B to C, A to B and B to C, the total value came out to be 9. Yes, this value is less than 12, so we swapped 12 with 9. Okay, this very simple process is called relaxation. So how you formally put it is, suppose like there's this node U and there's this node V, and I'll say the distance to get to node U is du, and the distance this distance is du, and the distance of going from U to V is cu comma V, and the distance of getting to V via some whatever other mean. Like over here, the distance of getting to node C was 12, yes, but the distance of getting to C from B was 9. So this distance from some other path, let's call this dv. Okay, so if du, yes, distance to get to u, plus the distance from u to v, c u comma v, yes, if this value is less than dv, the whatever value we have of getting to v before going to v from u, that value dv, if this is less than this, then dv is basically equal to this value, which is du plus c u comma v. And doing this process, this is called relaxing the node, this is called relaxation. Okay, so now we're done with this as well. So let's talk about A star algorithm now. For the sake of not making this video too long, I'll just quickly brief you on A star algorithm. A star algorithm is very similar to the Zig Star's algorithm. However, the difference between A star algorithm and the Zig Star's algorithm is that A star algorithm uses heuristics for navigating the search, and the A star algorithm will always give you, it's like a complete algorithm, so it will always give you an answer for any correct input, and it is more optimized as compared to the Zig Star's algorithm. In the Zig Star's case, we basically traverse through all the possible nodes. However, in A star algorithm, we choose the nodes wisely and making the algorithm more time efficient. The output will again be the same in both the cases, but this A star algorithm is much more time efficient as compared to the Zig Star's algorithm. So two key features: it's a complete algo. Complete means it will, for any correct input, you will get an output. Yes, and it is much more time efficient. So in case of Google Maps, where like we were using so few nodes over here, 1 2 3 4 5 6, we were using 6 nodes, but imagine from A to B, a very short distance, there are how many nodes? So if we have to like traverse all the possible nodes in this small map, it will take a lot of computational power, and to reduce that, we use the A star algorithm.
Alright, so if you've reached till here, thank you for watching the whole video. I hope I didn't bore you, and I wish you have a fabulous day ahead. Thank you, bye.